Okay, welcome back, everyone. Um, so I'm now sharing my screen so that you can see, and this is the program Stellarium that I was telling you about. The idea here is that, so this just shows what the night sky looks like wherever you are. In my case, I've set it for Forest Grove, Oregon, so that you can see my latitude and longitude down here. And this shows roughly what the sky looks like. Here I'm looking north. One advantage of having a virtual sky rather than the real sky is I can label things like the constellations. It'd be really nice if you could do that in the real sky when you wanted to. So here's Ursa Major, the Great Bear, and part of that is the Big Dipper. So actually I'm going to turn these labels off for now so that we can see the stars a little bit better. But you can also, you can mix and match. There's all sorts of things you can do. You can go to whatever location on Earth you want to see what the sky looks like. You can move to different times and dates to see what's going to be available to see on certain nights if you want to plan ahead for something. You can put coordinates on here so that this is kind of like latitude and longitude lines in the sky. There's the North Star, right very close to the North Pole, which is, you know, the axis of our merry-go-round that we're on. So that's the sky. Everything seems to rotate around the North Pole. Again, and I'm going to turn those off again so that we can see a little bit better. So I want to show you the first couple of objects that we're going to look at are galaxies. And you can think of it, you know, very much like our own Milky Way is a galaxy. These galaxies are just off of the tip of the Big Dipper. So if you can find the Big Dipper here, here's the handle of the Big Dipper. And then so I can do a search here, and I'm going to search for object M51, which is called the Whirlpool galaxy. And there it is. It shows me where it is, and I can zoom in and I can see the spot. So what I'd like you to do now is point your gaze, you know, with your eyes, go look in the direction that that is located, and then okay, so I'm going to switch out my sharing here. So I'm gonna, well, actually, hang on just a second. Let me show you one other thing while I'm here so I don't have to keep switching back and forth quite so much. So the next galaxy, so we're gonna look at a couple of galaxies. This one's called the Whirlpool galaxy, or M51, and you'll see why it's one of my favorites, I think, here in a minute. And then the other one that's in this same vicinity, close to the handle of the Big Dipper, is the Pinwheel galaxy. So I'm going to go ahead and do a search for that so that I can show you where that's located. And it'll show me where that is. And again, you can see, you know, it's very close in the same region of the sky. So again, I feel like it's really important, maybe I'm making too much of a big deal about this, but I feel like it's really important that you actually look, you know, point, I'm going to do it too, point your gaze in that region of the sky where that is. And some of the light from these objects is hitting your eye right now. It's just that your eye doesn't collect enough light. Your pupil's really small, much smaller than even my little telescope here. And your eye's not sensitive enough to pick up the light to be able to see the contrast, to see these galaxies. But they're there. I mean, you're getting light directly from them. So now all I'm going to do, the only thing I'm going to add to this is my telescope that I showed you earlier. I'm going to stop sharing this, and then I'm going to go and do go. Now I'm going to go and share. Now I'm going to share my iPad, which is connected to the telescope by Wi-Fi. So all that's happening is basically what's in the eyepiece of the telescope is getting sent by Wi-Fi to my tablet, and so that I can control the telescope with my tablet here. And then you can see, I set this up ahead of time, but I'll show you how I got to it here in a minute. So you see that Whirlpool looking object there, right? Here's the core, the center core. Turns out it's actually two galaxies, the main galaxy here, and then a smaller satellite galaxy, and they're actually interacting by gravity on each other, and so you can see the connection between them. And you know, the stars that are around here, the telescope is looking in that same direction that you and I were just looking with our eyes. And it just, because it can collect more light and the detector is more sensitive, it's able to see much more in that same region, okay? And I don't know about you, but this kind of blows my mind that we can see this, right? I mean, this is a collection of something like, I'll look it up in a second exactly what the details are, but it's hundreds of billions of stars, and in a collection that's similar to what we think our own Milky Way looks like if you could get outside of our Milky Way and look at it. It's something a little less, I think maybe 50 or 70,000 light years across. So it takes light traveling at 186,000 miles a second, you know, something like 50 to 100,000 years to get across this size of this. It's about 100,000 light years to get across our own Milky Way galaxy. And there's, you know, billions and billions and billions of stars making that up. It is something like, let me just actually go ahead and look this up for you, for myself. Actually, I've seen different estimates. So on here, it says 37 million light years. The most recent estimate I've seen was in the 20 some light years. But, you know, 20 to 30 million light years away. So two things to think about there. One is that the light has been traveling for, you know, 20 to 30 million years to get here, which is incredible to think of. The other thing is to realize it's not maybe surprising that we don't have a super precise distance for it, because it's a challenge. I mean, we have a pretty good distance estimate, but we know it's not 100 light years, it's 20 to 30 million. And it's worth pausing to think about, how do you measure the distance to something that far away when all you know about it is that it's this kind of smear of light that you can see in a telescope? It's worth stretching your brain a little bit to think about how we do that. In fact, a lot of the history of astronomy is perfecting techniques to be able to measure distances to things that are very difficult to measure the distance to. Okay, okay, so that's one galaxy. Again, it's out to kind of get your perspective here. This is outside of our Milky Way. So our Milky Way galaxy is a collection of billions and billions of stars shaped something like this, that we're inside of. We're out in one of the spiral arms, something, you know, analogous to something like here. And what you call the Milky Way, when you're under dark skies out camping or something, looking through the Milky Way, is that you're looking through the disk of this galaxy. So if you could see it from edge on, which we'll try to look at some other galaxies here in a little bit that are edge on instead, you can imagine billions of these are scattered throughout the known universe, billions of things, something like this, scattered throughout the known universe at various orientations, right? Just like you can see leaves oriented differently. So some of them are edge on like this, some of them are flat like this, some are anywhere in between. And what we call our Milky Way in the sky is because we're inside of one of these and we're looking through the disk. And so when we see it from close up, you know, across our field of view, that's what we see. And all of the stars that you see in the night sky are inside of our own Milky Way, our own island galaxy like this. And then outside of that are all these other galaxies scattered around like islands throughout the universe. Okay, so just to kind of get a sense of perspective of that. Okay, so now I'm going to kind of show you how the telescope works here a little bit more, because I'm going to actually go, so I'm going to take that away. And then you can see the cool thing about the way this particular telescope is set up is I have an interface now where I can type in coordinates, I can do a search for a particular type of object, or based on the telescope, it has GPS and it knows where I am and what time it is and so on. So it can anticipate what objects are visible in my sky right now, so it can make suggestions about what to look at. Whirlpool Galaxy is one of those suggestions. The Pinwheel Galaxy I pointed out on Stellarium to you a minute ago is another one it suggests, and I'm going to go to that one now. And so now it's going to go back to just, basically you can think of it as like it's a video camera in the telescope, essentially where the eyepiece, you know, as if there was a video. It's not quite like this because there's projected inside the telescope, but essentially you can think of it like there's a camera where you put your eye at the eyepiece. Okay, and so as it moves around, you see the stars move around, just like you can see that when you move your gaze around in the sky. And the really cool thing about this telescope is it has its own database, kind of like Stellarium, a little internal computer in the telescope, so it can match what it sees in the sky with its camera with its own database of what it knows about the patterns of stars in the sky. And so it can go and pattern match and find the things that I want it to find. And then it also tracks so that once I find it, I don't have to keep refinding it again. It compensates for the fact that the Earth is turning, and so this is moving across the sky. The object I'm looking at, like all the stars, are moving across the sky. And so it'll keep it centered in the field of view. Okay, and right now, we're just looking through, it's just like it's taking a video here. And the thing that we're trying to look at is too faint to be able to see with just basic video. So if I do hit that button, the enhanced vision mode, essentially what it's doing is stacking multiple images. So it's essentially taking a longer exposure and doing a little bit of correction to subtract out the background skylight. And then you can start to see, it'll improve as time goes on here, you can start to see the shape of the galaxy, and you can see more stars. You can start to see the shape of it standing out against the background again, and hopefully it's close to a full moon tonight, and despite the fact there's a penumbral lunar eclipse, still the moonlight is pretty bright, so the sky is not super dark, but I think we'll be able to at least see a little bit there. You can start to make out, so there's the core of the galaxy, and there is the spiral arms that you can start to make out there. That's a little better. The contrast is getting better. And you can just probably, depending on how good the video quality is over Zoom, you can maybe just start to see that you can understand why it's called the Pinwheel Galaxy, because the arms look like the arms of a pinwheel. Okay, and that one also is about 20-some million light years away, similar to the Whirlpool Galaxy we looked at before. And it also happens to be oriented mostly face on in terms of our line of sight where we're seeing it. Okay. So those are both in the Big Dipper. And I partly picked those because the Big Dipper is something pretty easy to find in the Northern Hemisphere, at least. For most people, many different times of night and times of the year, because it's pretty far north, close to the North Star. So it is what's called a circumpolar constellation, because it is close enough to the North Star that for people at fairly high latitudes, like I'm at 45 degrees north latitude, you can see it most times of the night and most times of year. Okay, I'm used to pausing for questions, and since this is just recording, there's no one there to ask questions, so you can post comments with questions if you have them. All right, so the next thing, I think the thing I want to do next is try to see, I don't have one planned in mind, but this will kind of show you what the possibilities are with this telescope, I think, is I just want to look for another galaxy, and I want to try to find one that is, well, let me just, so it even suggests some that are in the current constellation, so I'm just going to pick some other galaxies that are probably nearby, so it'll be easy to find. And I'm going to hope I find one that happens to be kind of edge on, so you can get a sense of what that looks like. If if I try a few of them and none of them are visible enough, then I'll be more excuse me, more systematic about it. But it's kind of, I think it's kind of worth seeing what you can do if you just, you know, just like you could get some binoculars. If you have binoculars, bring them out with you and just kind of scan around in the sky, and you'll see lots of interesting things. You can, at an even fainter level, you can do the same thing with a telescope and just scan around and see what you see. I forgot to mention, the field of view of this is about 1/2 degree in the sky across. So that's about the size of the full moon if you kind of orient yourself in how the sky looks. And so it's worth thinking about the fact that, you know, those galaxies I showed you filled up maybe 1/4 or a third of that field of view. So if your eyes were sensitive enough, you don't need any magnification, in other words, to see it, right? If your eyes were sensitive enough, they're filling up a reasonable, you know, it's like the crescent moon. It's filling up a reasonable fraction of the sky. And so you actually could see that. It's just that you're not collecting enough light. It's not, you know, your eyes aren't sensitive enough to see it. Okay, so this is a much more distant galaxy, so you can just see a fuzzy splotch there. And it's hard to tell what the orientation of that one is. So, okay, so I am going to be, anyway, but again, you just get a sense of the stuff that's out there, right? This is something, let's see if it tells me. It doesn't. We could look it up on Stellarium. It's just a galaxy. The NGC is New General Catalog number 5473. This is an object in that catalog. But it starts to give you a sense, right? We're still in Ursa Major. We're still in the Big Dipper, and so again, just gives you a sense that there's a lot of stuff out there in the universe, right? Let me see what I can find. It's Sunflower Galaxy 6. Let me try number 6. Another galaxy. We'll just try it. Telescope is slewing to, you can see the stars streaking across the field of view. It finds what it's looking for. It's also worth thinking about how you navigate in the sky, right? If you had to do this sort of hopping from star to star, looking for patterns, right? To be able to find the particular pattern of stars to orient yourself, just like you learn the constellations or whatever. Okay, I'm thinking that it's probably found it there. Yep, there it is. We'll turn on the enhanced vision and see if we can see it a little bit better. No, it's a little bit distracting. I kind of like the reminder of, you know, we're on the surface of this little planet Earth where fireworks are being set off, and, while we contemplate the universe millions of light years away. So this is another one. Okay, so here we go. This is good. All right, so this one you can start to see it's a little bit more edge on, right? So it looks kind of oval shaped, which you can imagine if you had something that was like this that you looked at from this kind of angle, it would look not like a spiral, but more kind of an edge on pattern like that. All right. So let's see. The next thing I wanted to show you is a globular cluster. Oh yeah, there we go. That's a really good view. Okay, I should be patient. Gonna let it get the best view it can here. The next thing I want to show you after this is going to be a globular cluster. So I'm going to start, so I've kind of taken you out to 20, 30 million light years away from home. We could actually go a lot further. There are galaxies that are over 10 billion light years away. Obviously, they look very, very faint, even with a big telescope like the Hubble Space Telescope. But again, you just start to get a sense of, just like you would see islands scattered around in the ocean or leaves scattered around on the ground, there are galaxies scattered around in every direction you look in the sky, wherever you point your gaze. Even if you can't see one, there are some light from a galaxy from millions of light years away is hitting your eye, and it's really out there. And again, this isn't a picture that I've pulled off the internet. Evidence from the explosion. This is a picture that is taken through that little telescope that I just showed you in real time, as we're talking here. Okay, in regions of the sky that you can look at yourself. Okay. All right. So the next thing I want to show you here is globular cluster back kind of on the outskirts of our own Milky Way again, if we kind of think of drifting back toward home a little bit. This one is called M3. The M stands for Messier, who was an astronomer that cataloged a bunch of non-star-like fuzzy objects in the sky. It was part of a search for comets. And so that's where the M numbers come from. And so this one's a globular cluster that I'm going to go to. It's about, we're back within our own galaxy, although it's kind of in the halo of our galaxy. So this one's about 34,000 light years from Earth, with something like 500,000 stars all packed into a fairly small region here. I'm going to hit go to, telescope will start moving to another part of the sky, and at the end I'll show you on Stellarium where this is, but you can also go and find it yourself. You can just look for M3. It's close to the star Arcturus, which is a bright star, at least right now on July 4th from my location here on Earth. It's in the, at about 11:30, it's in the south, pretty high in the southwest sky. So if you're watching this at a similar time from somewhere in the US, this summer, you probably see it in a similar location. And there it is, and you can tell it's much brighter than some of the galaxies we were looking at before, because you can see it fairly well even just on live video feed here through the telescope. And then I'm going to also do, it's still going, as soon as it locks on. There it goes. Now I'm going to turn on the enhanced vision again so that it'll give us a better quality image of it. And then there we go. Right, globular clusters is what these are called, for probably kind of obvious reasons. It's a cluster, a glob-shaped cluster of stars. They just look so beautiful, right? I mean, they're just like jewels in the sky, kind of jumping out at you and sparkling. Again, something like, if you're trying to picture this, look up in the direction of Arcturus, find that in Stellarium. The constellation Boötes, you'll find that on your star wheel. Look in that direction to have your eye pointed to pick up some light from this object, and it's something, and then know that it's something like 34,000 light years away, orbiting around the outskirts of our Milky Way galaxy, and something like 500,000 stars, all swarming together. Okay. Also, particularly old stars. I don't remember the number off the top of my head, but I think these are thought to be formed something like 8 billion years ago. So our sun's about 4.5 billion years old. So these are very, very old stars. get a better view. And I guess actually I can even zoom in a little bit here so we can see it's a little better. There you go. All right, so just think about what it would be like to live on a planet in orbit around one of those stars, and maybe there are, right? There might very well be civilizations around some of those stars, and what your sky would look like from that point of view. It's worth using your imagination to think about. Okay. I think one more object I have in mind to do for tonight, and then we'll save some other ones for other nights, is another type of object that is called a planetary nebula. And it's called that not because it actually has anything to do with planets, but because it looks like a planet through a small telescope. I think you'll see why. Oh yeah, there's a really good view of it. In fact, I'm going to save a picture of that for later. For all the cloudy nights that we'll have at some point, we got to have pictures saved so that we can look at things again. So, okay, so this next object I'm going to show you is called the Ring Nebula, and it's in the constellation Lyra, which is the harp, very close to the star Vega, which is one of the very bright stars in the sky. For me right now, it's almost straight overhead. Again, it's a pretty easy one to find on your star wheel or in Stellarium. It's also, if you've seen the movie Contact, Vega was the star that the message was supposed to have come from. And so it's about 25 light years away. And that was when Ellie Arroway and her crew found the message from the alien civilization that was communicating with us. That was where the broadcast was supposed to be coming from, was Vega, and which is a relatively close star, which is why the signal was so strong. Okay, so I'm going to do a search for the Ring Nebula, it's called, and M57 in the Messier catalog. Go to. While it's doing that, I'm going to go back and look at some information about it for you. So, so it is a pretty cool object for multiple reasons. It's close by the standards of what we've been talking about tonight. It's about 2,200 light years from Earth. And part of what's cool about it is that it's at least similar to what we think the future of our sun and solar system will be. So like I said, it's called the Planetary Nebula, and it's basically the end or a late stage of a star about the mass of our sun, when it runs out of hydrogen fuel to fuse in its core, which is what makes the star shine, and it kind of becomes unstable. The core starts to collapse and becomes a white dwarf star that you might have heard about. Very densely packed. Think of taking all the mass of the sun, or a lot of the mass of the sun, and making it about the size of the Earth. So it's super dense. A teaspoonful of it would weigh tons, or at least a ton. And the outer layers, though, end up getting sort of poofed off, right? They just kind of drift away, and make these beautiful, if you search for planetary nebulas on the web, you'll find just all kinds of amazing, beautiful pictures. And someday we'll look like that, right? Or in another, 4 or 5 billion years, a similar thing will happen to our sun. And let me show you a picture of it here. I think I just found it. Yep, there it is. And so let me turn on enhanced vision so we can see it better. You can probably see it looks like a little smoke ring, kind of. Sorry, as soon as there it goes, right? So among all those stars, there's a beautiful little, and I'm hoping that you can see, whoops. Again, a reminder, this is not a photo off the internet, right? This is an image taken through the telescope behind me here, as we speak. And hopefully you can see on the screen just a little hints, at least, of the color. Kind of in the middle part, it's kind of a bluish green in the middle, and on the outskirts, it's kind of a reddish color. There we go, that's much better. And I think you can see, again, I don't know if this comes through very well on Zoom, but you might be able to just make out the tiny star in the middle. That's the white dwarf. That's the core, you know, left behind when it's not explosive like a supernova. It just, these outer layers are just kind of shed off. And part of the reason I like showing this is because it's a reminder. So you can tell by the colors, you can tell the type of elements that are giving off the different colors of light. So the bluish green is probably oxygen, and the reddish color could be hydrogen and or nitrogen, if I'm remembering correctly. And so, you know, you've heard the poetic statement that we are all stardust, right? This is sort of an example of how that is actually literally true, that we're all stardust. We formed from material that was processed in stars that were originally mostly made of hydrogen and helium, processed in stars, and then kind of spit back out into the interstellar medium, the space between the stars, and then some material from past deaths of stars, like this, the Ring Nebula, and also more violently in supernova explosions from more massive stars, mixed together with these different elements. The iron was formed in supernova explosions, the oxygen that was formed in the processing of probably more massive stars than our sun, I'm thinking, if I remember correctly. But, you know, again, the basic idea is just that this material was created as a byproduct, if you want to think of it that way, of stars maintaining themselves against gravity, trying to make them collapse. Fusion, to make them hold themselves up, fills in the periodic table with heavier and heavier elements beyond just hydrogen and helium. And we're made out of that stuff, right? We owe our existence to the fact that our solar system is not a first generation, our sun, which formed at the same time as the rest of our solar system, is not a first generation star by any means. It's formed with the byproducts of the past lives and deaths of other stars. And because of that, we had heavier elements in our system, in the cloud that we have of material that we formed out of. And so, you know, it's literally true that the oxygen and the iron and the carbon in your body is there because of things like this Ring Nebula and lots of other kinds of, you know, like I said, nebula produced by supernova explosions and lots of other processes. But because of things like this, that we have stardust that makes us up. Okay, so again, something else to think about as you gaze up into the sky. Like I said, I think it's probably plenty for tonight. I think I'm gonna stop there. As you probably got a sense, there are lots and lots of other objects in the night sky. So we can have many, many installments of this kind of video. Do feel free to post in the comments about things that you'd like to see, types of objects you'd like to see, or questions that you have, and I'll try to reply and make more videos when I can. Okay, have a good night, everybody.